A sea vessel is installed with a sonar system to detect the depth of the seabed. A pulse of ultrasound is sent from the vessel, and an echo is received in 0.7 seconds. So, for us to no, the question wants us to find a few things. But the first thing we will do is actually make a sketch of what the circuit might look like. So in the interest of time, I went ahead and made a quick sketch of what this question is telling us about. So we have our vessel, right, on the surface of the ocean, right. It sends out a pulse from its sonar system, and then the echo is received in 7 seconds. So the question wants us to first find, so it says the speed of the sound in seawater is 5,400 kilometers per hour, and we're supposed to find the speed of sound in the seawater in meters per second. So let's start by working out question 1. So taking question 1, we're told that the speed of sound in seawater is 5,400 kilometers per hour, and we want to find the speed in seawater in meters per second. So to do this, what we'll have to do is convert this value here, 5,400 kilometers per hour, into meters per second. So in order to do that, I'm going to rewrite this value here and rewrite our units as a fraction. So it's 5,400 kilometers over hours. Now, the objective is to get rid of kilometers and express this value in meters, get rid of our hours and express this value in hours. So let me just write here quickly that 1,000 meters is equal to 1 kilometer, and 3,600 seconds is equal to 1 hour. So let me move this down a little. So it's 5,400 kilometers per hour. Now my objective is to get rid of, as I said, kilometers, express the value in meters, get rid of hours and express the value in seconds. So to do that, what I'm going to be doing is multiplying by 1 hour, right? Because I'm multiplying by an hour, that's same thing as multiplying by 1 hour in the numerator and 1,000 seconds. Well, not 1,000 seconds, 3,600 seconds in the denominator. Because basically what I'm doing is multiplying by 1 hour right here. And then, since I want to get to the form kilometers, I'm going to also multiply by kilometers in my denominator, so 1 kilometer. And then I'm going to express a kilometer in terms of meters. So that's basically 1,000 meters. So effectively what will happen is 1 hour will cancel my hours right here, and kilometer will cancel my kilometer, leaving my answer in meters per second. So if I should take out my calculator, so what I will do right now is multiply across and divide across. But first of all, let me cancel out the like terms in the numerator and the denominator. So hours will cancel with an hour right there. Kilometers cancels with a kilometer. So let me get out my calculator and I'm going to multiply across. So we have 5400 multiplied by 1000, and then I'm going to divide by this value here. Divide by 3600, and that gives me a value of 1500 meters per second. So I can therefore write that speed of sound in meters per second is equal to, again, multiply across, divide by 3600, and I get 1500 meters per second. So that's my speed of sound in seawater in meters per second. Now, part 2 of the question wants us to calculate the depth of the seabed. So again, let's look back at our diagram. So the sonar system sent out a pulse, it traveled some distance, right, and then went back up. So it took 7 seconds for the sound to leave the ship or the sea vessel, travel down, and then back up to the sea vessel. So basically, for the sound travel, it actually took half of 0.7 seconds this way, and then another half of 0.7 seconds to travel back up. So let's write that observation. So part 2, so we can say that time for sound to travel is 0.7 seconds, but the time for half of the journey is 0.7 seconds divided by 2. Now the reason why we're considering half the journey is because we want to know the depth, right? And the sound made basically one trip down and then another trip up. So to find the depth, we have to consider half of the total journey that the sound traveled. So if we divide 0.7, we get a calculator. So 0.7 divided by 2 is 0.35. So that's our time to travel down to the surface of the ocean floor. So the question wants us to find the depth of the seabed. So we can look at equation of motion, specifically this equation here that says that, let me get another color here, let's try this one. So let's say V is equal to S over T, where S is our displacement, T is our time, and V is our velocity. So we can rearrange this formula here to find displacement. So we can say S is equal to V multiplied by T. So we know the speed of the sound, and we know the time it takes for the sound to reach the bottom of the ocean floor. So we can write our V here is 1500 meters per second. So we're at 1500 meters per second, and all of that is multiplied by our time, which is 0.35 seconds. So 0.35 seconds. So if we plug this in our calculator, so we go calculator right here. So we'll go 1500 multiplied by 0.35, and that works out to be 524 meters. So that's the depth of the ocean floor. Now, part 3 in the question wants us to, part 3 says, if the frequency of the pulse transmitted by the sonar is 37 kilohertz, determine the wavelength of the pulse. So, for part 3, we can consider our equation for the speed of a wave. And that equation again is V is equal to F times lambda, where V is the speed of the wave, F is our frequency, and lambda is the wavelength. Now we're given the frequency, we know the speed, so we want to find the wavelength. So again, let's write down our values here. So V is equal to F is equal to, so the speed is 1500 meters per second and our frequency is 37 kilohertz. So speed is 1500 meters per second and our frequency is 37 kilohertz. So we want to find our wavelength, so we can rearrange our formula here to make lambda, which is for the wavelength, the subject of the formula. So we go lambda is equal to V over F. Now we can substitute our values in. So the speed is 1500 meters per second and our frequency is 37 kilohertz, which is the same thing as 37,000 hertz. So we can write 37 kilohertz as 37,000 hertz. And then we can call on the services of our calculator to find the wavelength. So we can write 1500 divided by 37,000 and we get a wavelength of 0.041 meters. So our wavelength is 0.041 because we round this value up to nearest value, which is 1. So our wavelength is 0.041 meters, or same thing as 41 millimeters. So again, this is Junior Roberts coming to you with realjuniorroberts.com. If there was anything in this video that you found challenging, please send me an email and I'll do my best to clear up any misconception for you. If this was helpful, please hit the share button, post your comments or questions below. Thank you for watching.